What's up, mathematicians? Justin here, and this is the first video in Unit 1 in our course on space or geometry. Unit 1 will be measurement, so in this first video I thought we should talk about what measurement is. So let's start with that question. What is measurement? Okay, so my personal definition for measurement is this. That measurement is the practice of assigning a number to a magnitude for the purpose of comparison. So let's look at an example of that, shall we? So here I have a book. This book is called The Thing Explainer. It was a gift actually from a friend of mine. And the thing about this book is it's pretty tall. It's taller than your average book. For example, here it is next to one of my favorite books about measurement. It's actually called Measurement, a book by Paul Lockhart. I recommend checking it out. Takes a little bit of a different take on measurement than we will, but really interesting book that I'm in the process of reading. But anyway, point is, you see this is sort of a standard size book, and you can see this Thing Explainer book is a lot taller than this book. And so I might wonder, will this book fit on my bookshelf? Well, I could just try it. You know, that would work. But another thing I could do is I could measure. So here I have a tape measure. And let's measure the height of the book. So here I go. I got 33.7 centimeters as the height of the book. And now I can measure the shelf. Let's find out how tall the shelf is. And I get, what, 34.2 centimeters. Okay, so let's go with those measurements up here. So we have 33.7 height of the book, and we have 34.2 height of the shelf. So since the book's height is a little bit less than the shelf's height, it should fit on the shelf. And let's see. Well, it's a bit of a squeeze, but yes, indeed, it does fit. And we can figure that out by using measurement. So that's what I mean when I say assigning a number to a magnitude. So we have the height of the book, a magnitude, and we assign a number to it. That's this number, 33.7. And then we have the height of the bookshelf, and we assign this number to it, 34.2. So we assign those numbers to make a comparison. We see, oh, since the book's height is less than the shelf's height, the book will fit on the shelf. I could compare it to the next shelf up, actually. So let's see how tall this next shelf up is. All right, I'll go ahead and use that tape measure again. And this one is only 33.2 centimeters tall. So once again, let's pull up the height of the book and the other height of this. So here we go. Height of the book, right? 33.7. Height of the shelf, 33.2. So since this height is bigger than this height, we would conclude that the book is not going to fit on the shelf. And sure enough, it won't fit. Now I could turn it sideways and make it fit, but it won't fit straight up. Okay, so that's, that might seem really obvious to you, but that's just to drive home the point that all we're doing is we're taking a magnitude, in this case a height of the book or height of the shelf, and we're assigning a number to that magnitude. What is it, 33.7 and 33.2 to the shelf, so that we can make a comparison between the two magnitudes. That is measurement in a nutshell. The practice of assigning a number to a magnitude for the purpose of comparison. Okay, so now that we know at least the definition of measurement, the next sort of logical question might be this. Why do we learn to measure? Why? What's the point of learning about measurement? And I'll give you a few of my reasons. There are probably others that I'm not going to cover, but here are a few that come to my mind as I think about why should we learn how to measure. First one is it's fun. And I think this might actually be the best one. And I really do enjoy measurement. I'm not being facetious about this. You can ask my wife. I am often seen, with a measuring tape around the house, measuring things, or, with other measuring devices. So I do think measurement is fun. So that's one reason to measure and to learn to measure. Reason number two. Let me pull it up here. Let's see. Reason number two, it is useful to us, to our lives. Measurement is something that most people use pretty frequently, maybe even on a day-to-day basis. So for example, if you're cooking or baking, you will be measuring things, measuring ingredients, right? If you're doing design or art, even interior decorating, like you want to figure out, will this couch fit in this room? You know, will there be enough space for these other things? Will it look good aesthetically? Measurement is involved with those types of things as well. And if you like to build things, I personally enjoy woodworking, architecture, that sort of thing. And so if you want to build things, do some woodworking, you're going to need to do a lot of measurement. So those are a few examples of ways in which measurement is useful to us. And let's see, the third one, society as we know it wouldn't exist without measurement. Now, this may seem a bit dramatic, but it's true. Okay, society, the society that we live in relies on measurement more than you might realize. So, for example, all the buildings that we have, you know, like even the house that I'm in right now, to build these things requires a lot of measurement. Let's see, like if we might need to measure the amount of water to water crops to feed the people in society. Anyway, there are many examples, many reasons why this is true. Society needs measurement. And in fact, this is one of the reasons that when we think about why is it that we have to learn math, you know, some of you out there watching might feel like, oh, you know, math is like boring or hard or both. It's just not my favorite thing to do. Why does society require me to learn math in high school, right? Because it's a requirement if you go to high school. And part of it is this: society needs math to survive and to continue to advance. And that's a whole nother can of worms that, you know, actually, I don't think I'm going to get into right now because I'll just end up off on a tangent. But it's just a matter of fact. Society needs math and measurement to survive. And so they say, you know what, you're going to learn it so that you can contribute to society. Okay, so those are three reasons. There are others, I'm sure, but those are three reasons that I thought I would highlight in this video. Okay. So now that we've talked about what measurement is, why we might learn to measure, let's talk about what it is, like what are some examples of things we can measure, some different types of measurement, okay? And so the first one that I want to talk about, yeah, okay, there's the question. What can we measure? So let's talk about some different things that we can measure. The first one that I want to bring up is length. And there's a long history with this. This is a picture of Egyptian rope stretchers. And so the Egyptians used ropes with knots tied in different, like certain intervals on those ropes. They used the ropes with knots to measure length. Okay, well, in modern day, we still measure length all the time, but we don't use ropes with knots tied on them. We use tape measures, right? Or rulers. So this is what we use to measure length. Now, length is probably the easiest thing to measure directly, and it's something that we, you know, one of the things that is most commonly measured of anything. But there are many other things we can measure as well, and many things we'll need to measure in geometry. So going past length, another thing that we need to measure is area. Okay, so how might we measure area? Here I have a sheet of paper, and let's say we wanted to find the area of this sheet of paper. Now, length we measure in units. I will typically use centimeters in this class, and when we want to measure area, we use square units. So square centimeters typically in this class. Now, this dot grid paper that I use has the dots spaced out 1/2 centimeter. So if we wanted to find the area, we might be like, okay, here is 1 square centimeter, right up here. Okay, so there I'm sort of highlighting, so maybe I'll shade it in there. So we can see there 1 square centimeter. Okay, now I could count out how many of these square centimeters it would take to cover this entire sheet of paper, and that is how I could measure the area of this sheet of paper. However, that's not very efficient, right? So it turns out measuring area directly is actually much more difficult than measuring length. I can't just take a tape measure and directly get the area. but I can use formulas. So formulas come to the rescue. I can take my tape measure and be like, oh, guess what? This particular, let me do it this way so you can read it more easily. This particular piece of paper is 21 centimeters wide. And then I can measure it up and say, okay, well, if I end at the perforation there, it looks like 29.5 centimeters tall. And I can multiply 21 by 29.5 and get the area of this sheet of paper. That is using a formula, the formula for the area of a rectangle, which is just the length times the width. Okay, so when we want to measure area, formulas will come to our rescue. Now this happens again with volume. Volume is like the next level up. And just like we use square units to measure area, we use cubic units to measure volume. Here I have a little cube, and let's see. I'll measure the length here of this cube. So this is 4 centimeters, you can see there. So this cube is 4 by 4 by 4. It is 64 cubic centimeters. 4 times 4 times 4 is 64. So if I wanted to measure, say, the volume of this room that I'm in right now, I could get a whole bunch of these cubes and just like stack them up and fill the entire room with these cubes. And that would give me at least an idea of the volume of the room. But that's super inefficient and also super expensive. Do you know how much it would cost to buy enough cubes to fill up this whole room, in addition to the amount of time it would take to actually stack them all up? It would take a long time. And even if I did that, the measurement that I got probably would not be that accurate when compared to using formulas. So once again, rather than measure it directly with cubic units, I can just measure the length, the height, or what's it, height, the length, the width of the room, and use the formulas. It's not a perfect box here, but I can account for those different things, and I can use once again use formulas to find the volume of something like a room. So a key point here is that the need to measure area and volume is one thing that results in a lot of the geometric formulas that we have. Now, you may have been asked to memorize some of these formulas in the past. Maybe it brings back some unpleasant memories, I don't know. But, and by the way, I won't ask you to memorize any formulas, but I do want you to understand this. It is actually much easier to use a formula to measure area or volume than it is to measure those things directly, okay? Formulas are your friends. They actually make your life a whole lot easier. When we get into shapes with curves, things get even more difficult. We may need formulas even for distances when we're talking about curves, in addition to area and volume. For example, I have a globe here. I love globes because they actually give you a much more, accurate picture of the proportions on the planet Earth, the planet that we all inhabit. And this globe is, it's not a box. There's nothing straight about it. It's approximately spherical, not exactly. But let's say I wanted to measure this globe. I can't very easily take a ruler to measure it. Now I could, and actually I have one here. I could take one of these flexible rulers, right? So, and sort of, do this and make some measurements and do calculations based on that. So, there are ways to sort of address the issue of distance by using flexible rulers like this. But in order to find, say, the surface area, the area around the globe, and also the volume of the globe, I'm going to need to use formulas. And so understand that, yeah, formulas are your friend. We won't actually spend too much time on formulas in this unit, but you can always look them up. Sorry about the noise there. The gardeners are mowing the lawn right outside the window there, which, by the way, the question of how much lawn there is to mow involves, you guessed it, measurement. So there's another example of measurement. Anyway, these are the things that we will be measuring in geometry class: length, area, and volume. We are not going to go past 3 dimensions because we happen to live in a 3D spatial reality. Now, you certainly can do geometry and measurement in higher dimensions, but we won't cover those things in this class. Also, I am leaving out an important geometric magnitude, and another magnitude that we could measure and we will measure in this class. Can you guess what it is? We will be discussing it later in this unit. But now I want to talk about some of the other things that we could measure, because measurement goes way beyond those three things: length, area, and volume. In fact, why don't you even pause the video and write down other examples of things that you could measure? Okay, do you have a list? Well, why don't you compare it against some of the things that I've thought of here? And so when I think about other things that we can measure, one of the first ones that comes to mind is weight. So we could, use a scale and measure. Let's see, what do I have here? Let me switch over to this. Whoop, didn't go. There it is. Okay, so I got my little scale here, and let's say I want to weigh one of my measuring instruments. So there we go, 72 grams. So that's a measurement right there, the weight of this tape measure. And let's see, what else? Well, another thing that I think about measuring all the time is, guess what? Time, right? We measure time all the time. And what do we use to measure time? I, wear a watch. I enjoy having a watch on my wrist because it enables me to keep track of time and not have to look at my phone all the time. But if you want to be more precise than a watch will give you, or at least this type of watch, you could get a stopwatch, measure time down to a fraction of a second. And you can get even more accurate than this, but this is accurate enough, precise enough for my needs. Okay, what else? Well, got a couple other measuring devices here I thought I'd show you. This is a light meter. It measures the intensity of light. So let's take a look at that here. Oops. There we go. So I gotta take this cover off and turn it on. And so what do we see? So the ambient light in this room right now is about 120 lux. But I could boost that up a bit. I got a flashlight over here. So I'll take my flashlight and shine, and you see it goes way up to what, 5,000 or so? Shining that flashlight, if I bring it closer, it's going to go up even higher, 7,000, 8,000. So this is a device for measuring light. And then I have this one here. This measures sound. And let me go to the slow setting. So let's quiet down here. One more is back. So we're running maybe around 50 decibels with the ambient noise. And if I'm talking, it's running more, maybe around 80 decibels. So this thing measures sound intensity. Can you think of any other things that you might measure? In fact, a couple things that I think of, a couple things that come to my mind are, what if we wanted to measure color or measure a musical note? What would we even be measuring in those examples? Those are interesting questions to think about, and I encourage you to do so. Okay, so we've talked about what measurement is, and we talked about why we learn to measure, and also about some of the different types of things we can measure. The next thing I'd like to spend a few minutes talking about is this, the distinction between magnitude and quantity. So if you recall, my definition of measurement is the practice of assigning a number to a magnitude. But what is a magnitude? And what distinguishes it from quantity? And to answer this question, to address this, I'm going to turn to a version of Euclid's Elements, a commentary on Euclid's Elements by James Hamblin Smith, an old version that I've spent a fair amount of time with, find fairly interesting. And so, yeah, this is an old, I found this PDF online. I believe this is, 1883, something like that. Hopefully I got that right. If not, oh well. But yeah, as you can see, it's a version, it's a commentary on Euclid. And towards the beginning of this particular text, James Hamblin Smith makes the following comment about magnitude, saying this: a magnitude is anything which is made up of parts in any way like itself. Thus, a line is a magnitude, because we may regard it as made up of parts which are themselves lines. So a line could be thought of as being made up of smaller lines. So a line is a magnitude. you know, a counter example to this would be like a marker, right? Here's a marker, and this marker is not made up of smaller markers, right? It's just one marker. It's not made up of smaller things like itself. And so this is not a magnitude. A marker is not a magnitude, but a line is a magnitude because it can be seen as being made up of smaller parts like itself. One way to, one key thing to understand here is that a magnitude, oops, let me go back to this one. So, oops, keep going. All right, I'm still working on my systems. I'll get it figured out. So a magnitude, right, is a continuous variable number. A magnitude is continuous, whereas a quantity is discrete, meaning that you have one of it or two of it or three of it, but you would never have, for example, 3.12 markers, right? Like this is just 3 markers. It's not like 3.12, but you could have a line of length 3.12, right? So a line is a magnitude, it's continuous, and something like a marker is a quantity, it's discrete. Now, when we measure, we are measuring magnitudes, okay? I would never say that I'm going to measure the number of markers in this mug, right? I would say instead, I'm gonna count the number of markers in the mug. However, you know, I could measure the amount of time that it takes me to count. Should we do that? Should we, you know what, let's do it. So here, I got my little stopwatch here, and I'm gonna start it hang on, okay, so here we go, go. Let's say one, oops, hang on. Let me start it again. I'm gonna go from this direction. Okay, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Exactly 30 markers. Oops, I forgot. Anyway, it took me about 20 seconds to count the 30 markers in this mug. Okay, so see, isn't measuring fun? More examples of measurement right there. Now, this was not intended to be a race, but hey, if you can count markers faster than that, you know, tell me about it in the comments. So one more quick comment that I'll make before we wrap up is just a quick note about precision. And when we measure things, sometimes we measure things that are really big, sometimes we measure things that are really small, sometimes it's hard to know, like, how precise should I be? Sort of how many significant figures? Am I measuring down to the nearest millimeter, the nearest tenth of a millimeter, the nearest centimeter, etc.? And typically, and now this is not always the true, but the larger the measurement, the less precise you need to be in terms of getting down to millimeters or fractions of millimeters. Now, that's not always the case, but typically that's what happens. And you can see that in the measuring devices. So I have a few measuring devices to show you here. The first one is the most precise one. This is a caliper. So you can see this here. And let's see, I don't know if this is focusing, but you can see here, this measures up to a fraction of a millimeter, right? So I can measure things very precisely with this device, and within the space of 1 millimeter, it goes through a half circle. So that's very precise. Less precise would be something like this ruler. Now, this ruler, you can see, at least in this part, we have 0.5 millimeters being marked. So this measures to the precision of about 0.5 millimeter, whereas this is a smaller fraction of a millimeter. I got my 2-meter tape measure, and we can see this one. We have the measurement precision goes down to the nearest millimeter. And now I've got this thing right here. This is a 100-foot long or 30-meter long tape measure. So if I want to measure a really much longer distance, and if we look at this one on the metric side, we see that it goes down to 2 millimeters. So the distance between one line and the next line, instead of being 1 millimeter, is 2 millimeters. So you see that as we get to longer lengths, less precision. I would never use this, let me switch back to this. I would never use this, you know, really big tape measure to measure, for example, something quite small, you know, like this cube, okay? This cube, I would measure, if I want to be really precise, I could measure it with my caliper. But if I just want sort of to the nearest millimeter, I could just measure here with my tape measure, which takes it to the nearest millimeter. Okay, so that's a quick note about precision. All right, this has already gone on for what, about almost a half an hour. So as you can probably tell, I could probably just go on and on talking about measurement because I love measurement. However, it is time to wrap up. So as always, thank you for watching, and we'll see you in the next video. Bye-bye.